Hey there, so in this video we are going to do some random experiments, okay? These experiments are going to be related with arrays and we are also going to do some experiment related with variables. So let's quickly get started. Let's declare one array of integer type, or let's declare one array of character type char arr, and let's initialize it with, let's say, three characters, small a, small b and small c. Okay, so basically this ARR array is going to be created in the memory, and this is how it is going to look in the memory. See, we are going to have three elements a, b and c. Okay, and all the elements are of character type. We are going to get 3 bytes of memory. Okay, so this is how it is going to look. Now let's try to access each and every element of an array. So what I'll do is I'll write cout ARR of 0. This is how I'll access the first element. Then let's access the second element as well. I'll write ARR of 1 because second element will have index as 1, and then I'll write ARR of 2. Now let's compile and execute this code. So I'll write g++05 playing with arrays.cpp. Let's execute it. You can see the three elements are getting printed properly, a, b and c. Okay, now let's see what happens if I try to do something like this. Let's see what happens if I try to print ARR of 3. Now ARR of 3 is actually not a correct index to access. Okay, if you see, this array has size as 3 and the largest number is 2. Largest possible index is 2. Okay, so you should not ideally write index which is greater than 2. Okay, because the last element, which is c, is having index as 2. Okay, so it is interesting to see what is going to happen if I write ARR of 3. Okay, similarly it is also interesting to see what is going to happen if I write something like ARR of -1. So basically what we are trying to do is we are trying to access illegal index position. Okay, even this position is illegal, and even this index value is illegal. So let's see what happens. I'll compile the code. You can see compiler is not giving any error. Okay, so compiler is totally fine with it. Okay, compiler is not throwing any error, and let's execute it. You can see it got executed and it is printing something random. Okay, so at this place it is printing something like this question mark, and over here it is printing some empty character. It went on a new line, but right now we are not able to see anything. So basically we are getting something random, something weird. Okay, let's understand why this is happening. For that, let me go back to the whiteboard to understand why this thing is exactly happening. See, we have this RAM, this is our primary memory, and in this primary memory we have this ABC stored over here. Okay, so whenever we access 0th index of ARR, this is the 0th index, this is the first index, and this is the second index. Okay, now this RAM is an infinite memory, and obviously we are going to have some content in all the bytes. Okay, no byte is going to be empty. There is going to be some content in all the bytes, and that's why, see, before this small a there can be some content in this byte. Let's say it is question mark. Okay, and over here in this byte as well we are going to have some character. Let's say it is /0 or null character. Okay, over here let's say we have small b. Over here let's say we have x. We are going to have some content everywhere, right? So what happens is, see, we have this array which starts here and it ends here. So valid indexes are from 0 to 2, but C++ don't have any index bound checking. C++ leaves this to the programmer. C++ do not enforce any index bound checking, and that's why programmer is free to use any index. Okay, and that's why if you use ARR of 3 or if you use 3 index, then basically you're trying to access this element, because array starts from here. 0 index is this element, 1 index is this element, then this is the index 3 element. So that's why in this case whenever you write ARR of 3, you're trying to access this element, and whenever you write ARR of -1, you're trying to access this element over here, and that's why you don't get any error, but you get some garbage value, some random answer which you cannot predict. But ideally, always remember, as a programmer you should not access illegal position or illegal indexes. Okay, whatever indexes are allowed for your array, only those indexes ideally you should access. You should not access the element or indexes which are not inside your range. Okay, which do not fall in your range. So I hope you are clear with this first point. we just talk about valid and invalid indexes. And always remember, in C++ we do not have something called as index checking or index bound checking, and that's why all the indexes are valid when you use subscripting operator. Okay, now let's discuss next point about the arrays. Okay, so let's say, let me delete all these things. Let's say I have an integer array ARR and it has size as 10. Okay, but I'm giving initializer list, and in that initializer list I'm giving only one initializer or only one value. Then what is going to happen? See, we have already discussed this, but let's see it in the code. I'll print the entire array, so I'll write a for loop to do this. See, I'm printing the entire array, and after this for loop I'll also write one endl just to print one new line. Okay, let me clear this terminal now and let's compile and execute this code. You can see it is printing 1 followed by all zeros followed by 9 zeros. Okay, so as we have discussed in one of the previous video, whenever you give initializer list and if the number of initializers in that list are less than size, then the other elements of an array will be initialized with 0. If your array is of integer type, it is going to be initialized with /0, a null character, if your array is of character type, and they are going to be initialized with 0.0 if your array is of type float or double. Okay, so I hope you are clear with this point. When you give initializer list and if the initializers in that list are less than number of elements or size of an array, then rest of the elements will be initialized with either 0 or /0 or 0.0. Let's see what happens if I don't give any initializer. I keep this list empty. So let's see what happens in this case. Let me compile and execute. You can see all the array, the entire array is getting initialized with 0. Okay, so if you have this use case, sometimes this might happen that you want to create an array and you want to initialize the entire array with 0. Then in that case you can do something like this. Just give empty initializer list or initialize the list with only one element, and that is also 0, and then your entire array will be initialized to 0. Okay, so this was one small point. Then let's see what happens. Let's say this array is of size 3. Okay, let's see what happens if I give more number of initializers. So let's say 1, 2, 3 and 4. So in this case what I am doing is, my size is 3, but in the initializer list I am passing more number of elements. So what happens, you can see editor has started giving an error. Let's see what compiler says. Compiler is saying too many initializers. Okay, so basically you can give less initializers, that is fine, but you cannot give more initializers. Okay, so this is a very important point to remember. The initializer list can contain less number of elements than the size of the array, but they cannot contain more number of elements than size of the array. Okay, so yeah, I hope you're clear with this point. Now let's see one interesting thing with integer array. Let's see what happens if I write something like this. Let's see this very carefully. Let's see what happens if I write something like this. See, as we know, in array we keep homogeneous data. Okay, so this is an integer array. Okay, and in integer array you are supposed to store integers, but in this case what I am doing, in the initializer list I am passing one integer, then one character, and then one double value. Okay, this is a double value. So whether this is valid or not, okay, see, editor is not giving any error, that means it can be valid. But let's check once again. Let's check with the compiler whether compiler says anything. So let's compile this code. You can see it is throwing one error. It is saying narrowing the conversion of something something. Okay, so for now what I'll do is I'll remove this 10.2 from here. Okay, and I'll just keep these two things like 1 and small a. Okay, let me change the size, or let me remove the size and let me write 2 over here. Let's see whether this works for 1 and small a, which is a character. Small a is a character. Let's see. Let's compile. You can see this time compiler is not throwing any error. Okay, in previous time it was throwing an error because of the double constant. I'll explain you what is this error, but you can see right now it is not throwing any error. Now why this is happening? See, in the initializer list we have one character, but ideally the array stores homogeneous element. So why it is allowing us to pass character inside the initializer list? So the answer to this question is implicit typecasting. Okay, now this is very important. See, understand this very carefully. In C++, we have something called as typecasting. Okay, now whenever you create a variable, let's say you create variable of integer type, let me name it as var, and then you store some value in it, which is again of integer type. This is an integer constant. So in this case, compiler don't need to do anything. Variable is of integer type, your value is of integer type, so they are compatible with each other, and then the value can be stored in your variable without anything. Okay, but let's assume this scenario where your variable is of integer type but the value is of character type. So in this case, what will happen? So in this case, there is something called as typecasting. So what we can do is we can convert value of one type into another type, and this process is called as typecasting. Okay, if you convert value of one type into another type, then it is called as typecasting. Now this typecasting can be done in two ways. First way is called as implicit typecasting, and second way is called as explicit typecasting. So what is implicit typecasting? Implicit typecasting means the compiler is going to do typecasting for you. You don't need to do anything. You can see in this case, let me comment out this entire thing. Okay, and let me write cout var. Let's see what happens. Let me compile the code, and let me compile the code. You can see it got compiled successfully. That means compiler has no problem with me storing this character into this integer variable. Now let's execute this. You can see it is printing 97. Okay, and if you remember, 97 is a ASCII value of small a. Okay, so basically what compiler is doing is compiler is converting this small a into integer. Okay, and how it is doing the conversion? Compiler is storing ASCII value of small a. So this is called as implicit typecasting. Compiler is doing the typecasting for you. Okay, again I'll repeat, implicit typecasting happens when compiler does the typecasting. Okay, you don't need to do anything. As a programmer, you don't need to do anything. And there is second type of typecasting, which is called as explicit typecasting. So in explicit typecasting, you tell the compiler, as a programmer, you tell the compiler that what typecasting you want to do. Okay, compiler is not going to do that for you. So I'll explain you how explicit typecasting is done little bit later, but right now I hope you understood what is implicit typecasting and what is explicit typecasting. Okay, now let's come back to our problem. See, in this case, now I'll remove this var and this cout from here. Now in this case, what is going to happen? The exact same thing is going to happen. In our initializer list, we have one character, but our array is of integer type. So what compiler is going to do? Compiler is going to do implicit typecasting for us. Now when compiler does implicit typecasting and when it doesn't do implicit typecasting, so whenever compiler feels confidence in converting one data type into another, whenever compiler feels that there is not going to be any data loss, there is not going to be any issues with the conversion, then it does implicit typecasting. But whenever compiler feels that if he does implicit typecasting and if there is going to be some data loss or there is going to be some issue, then in such scenarios compiler is going to throw an error, and then compiler is going to ask the programmer that if you want to actually convert this value into another data type, then do it explicitly, do it yourself. That is when the programmer is going to do explicit typecasting. Okay, so in previous example, let's first run this code while compiling it. So I'll compile the code and I'll execute it. You can see it is storing 1 and 97 in the array. Now if I write, let's say 10.2 over here, and now if I compile it, let me change this to 3. Let me compile it now. You can see now we are getting an error. What this error is saying? It is saying narrowing conversion of this value from double to int. So basically it is saying this double value is getting narrowed. Okay, because see, double is going to be a value in which you are going to have fractional value. Okay, so when this value gets converted into integer, there is going to be some data loss. So in this case, the compiler is giving an error saying that there is going to be some data loss. Okay, But if you still want to convert this value into integer, if you still want to tell the compiler that okay, I'm okay with the data loss, I still want to convert this value into integer, then you can do explicit typecasting. See, what is the syntax to do this explicit typecasting? It is very simple. You just need to write this explicit typecasting operator in front of the value. Okay, this is how it looks. It is like open and closing parentheses, open and closing round brackets, and in these round brackets you need to write the target data type. So in this case I want to convert it into integer, so I'll write int. Okay, so basically I'm telling the compiler that I want to convert this double value into integer. So this is how you do explicit typecasting. So now if I compile the code, you can see it is getting compiled successfully without any issues, and now if I execute it, you can see it is printing 197 and 10 because this 10.2 is getting converted into 10. Okay, so I hope you understood what is explicit typecasting, how to do explicit typecasting. You need to write this operator in front of the value which you want to explicitly typecast.